Hello, Algebra 2 classes. Please get your notebook out, write down today's date, and join me in reviewing today's success criteria. So hopefully by the end of this lesson, we will be able to determine values for which a rational expression is undefined. We'll be able to evaluate rational expressions, simplify those, and also simplify rational expressions with opposite factors. As we look at our definition, we'll be reminded that a rational expression is an expression of the form where we have a polynomial p of x in the numerator and a polynomial q of x in the denominator, where we know that q cannot equal 0 because division by 0 in math is undefined. The first thing that we will look at is being able to restrict the input or the domain values by saying what our variable cannot equal to. So we look for what number will create a 0 in the denominator, and that number we will have to say we cannot equal that number because that is where the function would be undefined. So if we look at our first problem here, we can see that all we have is an x in the denominator, so x cannot equal 0. If we look at our second one, we have 2b plus 5 in the denominator, and so to figure out what will produce a 0, we can actually set the denominator equal to 0 and then solve that equation, and we will see that b cannot equal a negative 5 halves because that's when we will produce a 0 in the denominator. We can see that in number 3, sometimes our denominator will have 2 or more factors, and then that means we will have 2 or more values in which we will have to say that will produce a 0, and we'll have to restrict the domain. So if we look at this, what number plus 2 would give us a 0? We'll know that x cannot equal negative 2. That would produce a 0 in this first parenthesis. And then what number minus 6 will give us a 0? X cannot equal 6. That would produce a 0 in this parenthesis. If we look at example 4, that you'll see that sometimes to be able to figure out what numbers we need to restrict, we will actually have to take and factor the denominator first. And so if we look at what two numbers multiply to 8 and add to 6, that would be 2 and 4. And so therefore we would say that a cannot equal negative 2 because that would produce a 0 in that first parenthesis, and a cannot equal a negative 4 because that would produce a 0 in the second parenthesis. As we move on to simplification, I'm going to ask you to go back and recall. A lot of times when we can take a concept that we already know and link it together with a new concept, that's going to help us really clarify that learning in our head. So if we go to simplify this fraction, we probably don't even think about the process anymore, we just do it. But if we look at this fraction, 36 over 63, we can see that both of those have a factor of 9, and so this would be 9 times 4, and this could be 9 times 7. And we've talked before about how if we have a 1, and that form of 1 changes, the form of 1 changes looks very often, we can see that what we have here is a 1, so that 9 over 9 will create a 1, and that will leave us with negative 4/7. The whole idea of how we simplify today with our rational expressions is going to be based on this very same concept. This same concept we used when we talked about simplifying algebraic expressions. If we look at 3xy divided by, if we take 18, 18 can be written with a 3 times 6. If we look at x squared, that's x times x. And if we look at y squared, that's y times y. We can then say, well, 3 over 3, there's a 1. X over x, there's a 1. y over y, there's a 1. And so when I go to write my answer, I have removed everything from the numerator, leaving a 1. And then the denominator, we're going to have a 6, an x, and a y. And so although we've used this process in different ways for several years now, we're now going to look at it as how it applies to our rational expressions. So to be able to simplify, we are first going to need to factor. And so if we factor this first one here, I can see that there's a GCF of 2. And if I take that GCF, I'll be left with an x plus 4. If I look at the denominator, I can see a GCF of 5. And if I divide out of 5, I'll be left with x plus 4. And so you can see now that those x plus 4s will cancel out, and we're going to be left with the answer 2/5. Since the variable was removed from the problem, I don't need to put any restrictions on what the variable can be. If I look at the next one, I'm going to look to factor first. I'm going to take a 3 as a GCF out of the numerator. That will leave me with x minus 2. I'm going to take a 2 as a GCF out of the denominator. That is going to leave me with an x minus 2. Those x minus 2's will cancel out, and I will be left with the answer of 3/2. Once again, since my variable is no longer in the problem, I don't have to write down any restrictions for the domain. And then the last one of this type, I'm going to start with the numerator here and take out a GCF of 7. That will leave me with y plus 5. In our denominator, I'm going to take out a GCF of 5. That'll leave me with a y plus 5. If we look then, we can see that we have those expressions that are the same, and they will cancel out, and that will leave me with a 7/5. We will see that we can simplify using the procedure that we just did, and that any types of factoring that we have done in the past are fair game for this. So if we look at our polynomial here, we have a quadratic polynomial. We're looking for two numbers that multiply to 6, that add to 5, that are 2 and 3. In our denominator, looking for two numbers that multiply to 12, that add to 8, that is going to be 2 and 6. And so what we see is that our x plus 2 and x plus 6 can cancel out. And so in the numerator, we're left with the expression x plus 3. In the denominator, we are left with the expression x plus 6. Please keep in mind that these are expressions, they are grouped together, and so therefore we cannot cancel like the x with the x here and then be left with 3/6 or 1/2, okay? So that is not something that we can do. We're going to leave that as the expression x plus 3 over x plus 6, and then we will have to say that x itself cannot equal -6 because that'll produce a 0 in the denominator. If we look at our next one here, two numbers that multiply to -2, that add to -1, x minus 2, x plus 1. And then two numbers that multiply to a +2 and that add to a -3, that is going to be a -2 and a -1. And so once again, we've got a common factor, and then we are going to be left with x plus 1 over x minus 1. Same thing as the last one we did. We cannot take and cross anything additional out. These are groups, and x plus 1 can only cancel with another x plus 1, and an x minus 1 can only cancel with another x minus 1. We do need to say that x cannot equal 1 in this particular problem. All right, so for this slide, go ahead and write these problems down and then pause the video and work them out. And when you come back to the video, you can check your answers. All right, so looking at the answers here, two numbers that multiply to negative 10, that add to a negative 3, x minus 5, and x plus 2. And then two numbers that multiply to a negative 2 and add to a positive 1, x plus 2 and x minus 1. And so therefore the x plus 2's are going to cancel out. We are going to be left with x minus 5 over x minus 1. And we will need to say that x cannot equal 1. If we look at the next one here, in the numerator, two numbers that multiply to negative 42 and add to a positive 1. It's going to be a y plus 7 and a y minus 6. And then our second type here, we're going to factor a difference of two squares. So that's going to be a y plus 6 and a y minus 6. And we can see that the expression y minus 6 is going to cancel. And we are going to be left with y plus 7 over y plus 6. And then have to note that y cannot equal negative 6. Well, if we look at the numerator of the first problem here, you're going to see that we have 4 terms. And this was a concept that we reviewed last week, grouping by factoring by grouping when we have 4 terms. So I'm going to take first and use that process to factor this numerator. So just as a review, you take the 4 terms, break them into 2 groups, look at the first group and determine what is the greatest common factor, and then divide that out. Look at the second group, determine what the greatest common factor is, and also whether it's positive or negative, and then divide that out. And then what we should have is this common factor here, y minus 3. And then our other factor we create by pulling together our greatest common factors from group 1, y squared, and group 2, plus 1. So what we have here, this is now going to become our numerator. And then our denominator here was a trinomial that's going to factor pretty easy. Two numbers that multiply to negative 6. So I will need 1 positive and 1 negative. And that are going to add to a negative 1. So that is going to give me a negative 3 and a positive 1. I'm then going to be able to see that the expression y minus 3 will cancel with the expression y minus 3. And that I will need to take then, and the numerator will be y squared plus 1. The denominator in our answer will be y plus 1. And we will need to state that y cannot equal negative 1 because that'll produce a 0 in the denominator. If we look at our next example here, you could see that our numerator contains a greatest common factor in that binomial. So I'm going to take first and factor out a greatest common factor of 2n, and that is going to leave me with n minus 7. In the denominator, I see there's also a greatest common factor of 4, and I'm going to factor that out. That's going to leave me with n squared minus 4n minus 12. And now I'm going to look in the numerator. Can I factor what was left in the parentheses any further? And with n minus 7, I cannot. When I look at the denominator, my GCF was 4. I'm going to look at this. Two numbers that multiply to a negative 12 would be 1 positive and 1 negative. And I need to be able to make a negative 4. So that is going to be a negative 6 and a positive 2. So when I go to look to see if there's anything that I can simplify, the only thing that I see is that this 4 right here, we know that that 4 is 2 times 2. and therefore we will have this 2 cancel with this 2. In the numerator, I'm going to have n times n minus 7. In the denominator, I'm going to have 2 times n plus 2 times n minus 6. So we don't have a lot cancel with that, and that's fine. I am going to have to then say that n cannot equal -2, that'll produce a 0, and n cannot equal 6, that will produce a 0. All right, so why don't we go ahead and you can write these problems down and stop the video and simplify the problems on your own. When you are finished, start the video up and check your answers. Looking at the first problem, if we look at the numerator, I do notice that there is a GCF of 2. And so I'm going to factor out a 2. That'll leave me with x squared minus 6x plus 9. If I look at the denominator, that is going to leave me, I'm going to start with the GCF, then it's going to leave me with x squared minus 9. In my numerator, then I'm going to check to see if it factors any further. It does. That is going to be x minus 3 times x minus 3. My denominator is a difference of 2 perfect squares, and so that is going to be x plus 3 and x minus 3. So we can see that we're going to have 1 x minus 3 take out this other x minus 3. Remember that we can only have 1 in the numerator, take 1 in the denominator out. It cannot take out this other x minus 3. So my final answer then is going to be 2 times x minus 3 over 3 times x plus 3. And then my restriction will need to be that the denominator x cannot equal -3, because that will produce a 0 in the denominator. If I look at the second problem on this page, I'm going to be reminded that when I factor a cube, that if it's a sum of a perfect cube, that I take a plus b times a squared minus a times b plus b squared. So when I go to factor a cube then, like I have in the first step here, m to the third plus 8, that is going to be m plus 2 times m squared minus 2m plus 4. So if you need to, you might need to go back and review how to factor a cube, whether you have, like we did in this one, a sum or a difference. And then we're going to factor our denominator is a difference of 2 perfect squares, so that's going to be m plus 2 and m minus 2. And then I'm going to see that those are going to cancel out, and I'm going to be left with m squared minus 2m plus 4 over m minus 2. And then we'll have to put that m cannot equal 2. All right, so here we have some additional practice problems simplifying. You can see we have cubes and we have a difference of 2 perfect squares. So go ahead and write the problems down, stop the video, factor those, simplify them, and then check back for your answers. All right, so if we look at the first problem here, I see that this is a cube that I'm going to need to factor. So I'm going to say that this is p minus 4. So taking the cube root of each of those, and then that's going to be p squared plus 4p plus 16. And then in our denominator is going to be p plus 4 and p minus 4. And we're going to see that we can cancel out those two factors. And so our final answer in simplified form is going to be p squared plus 4p plus 16, and that is going to be over p plus 4. And then we will have to say that p cannot equal negative 4. In our next problem, we need to factor this cube. So cube root of x to the third, cube root of 8. Then this will be x squared minus 2x plus 4, just following that cube pattern. And then we're going to look at x plus 2 and x minus 2 being the factors of x squared minus 4. And then I'm going to be able to see that I do have something that cancels. And my final answer here is going to be x squared minus 2x plus 4. And this is going to be over x minus 2, where x does not equal 2. The last part of our success criteria is being able to factor when we have opposites. And so if you think about very basic, if you take a number and the exact number, we know that that simplifies to a 1. But if we have a number and its opposite, that is going to simplify to a negative 1. And so that is the exact thing that happens here. When we look at this y is positive, this y is negative, this is negative, this is positive. And so what we have here are opposites. So when they simplify, we can cancel those out, but it's to a negative 1. And so that could be intertwined with our problem now. So if we look at this one over here, our GCF is going to be 2, and I'm going to have a 7 minus x. In the denominator, I have a x plus 7 and an x minus 7 because I have a difference of two perfect squares. And then what I could see here is that I have factors that are opposite of one another. Those factors are going to cancel, but it's going to be a negative 1. But then I have a 2 left in the numerator, and I have an x plus 7 left in the denominator. Once again, x cannot equal negative 7. That'll produce a 0 in the denominator. We'll now have to watch for that idea of opposite factors. And so when we look at our first problem here, we're going to see that two numbers that multiply to negative 32 that add to negative 4 are going to be negative 8 and positive 4. And then we have a difference of two perfect squares, which is going to be 4 plus x, is going to be 8 plus x, because the number there is a 64, 8 plus x, and an 8 minus x. And so what we will see is that what we have here and here are opposites. That is going to cancel but to a negative. And then in the numerator, we're going to be left with an x plus 4. And the denominator, we're going to be left with an 8 plus x. And we can use the commutative property there and say it's x plus 8. And so we then have to say that our variable x cannot be negative 8. That would produce a 0 in the denominator. And then if we look at our last problem here in the numerator, two numbers that multiply to a negative 2 and that add to a 1, positive 2 and negative 1. In our denominator, that's going to be 1 minus x and 1 plus x. Sorry, 1 minus x and 1 plus x. I just didn't write it down right. And so we can see that we have opposites right there. That's going to leave us with a negative. In the numerator, then, we're going to have x plus 2 left. In the denominator, we're going to have 1 plus x, which we can write as x plus 1. And then we are going to have to say that our variable x cannot equal negative 1.